Is a bit of biology with Mr. Rock, and today we are going to be talking about Punnett squares. First question that you should have is, what is a Punnett square? A Punnett square is used in genetics, and it is a diagram that shows the probable traits of the offspring from a cross between two parents. So just to be clear, when I say the word cross, that is a fancy word in genetics for if these two parents have sex. We're talking about like sperm meaning egg, like, so what are their kids going to look like if they cross, or if they like create offspring, what are their kids going to look like? So we do this for one trait, and the trait that we're going to be talking about today is widow's peak. Widow's peak is a dominant trait, and if you can see it on the video here, this video is kind of pointing to it. There's a red. Widow's peak is where your hairline is not straight across your head. This hairline is like straight across the head. The one on the left comes to a peak. It's called widow's peak. It is dominant, and we are going to let the dominant allele be represented by a big W, and the little one, which is a straight hairline, be represented with a little w. So if you have not seen Fundamental Genetics Terms video, I would recommend you go back and watch that, because I'm not going to be explaining genotypes and phenotypes in this video. I'm not going to explain the language. I'm showing you how to do a Punnett square. So this is our problem right here. The problem is cross two parents who are heterozygous for widow's peak. We are using big W to represent widow's peak and a little w to represent straight hairline. Whenever you're doing these problems, your first step when doing a Punnett square is identify the parents. So you usually get these problems in words. Like, what I mean by that is saying that both parents are heterozygous. So you need to figure out what their genotypes are, and for their genotypes, you should have two letters. So heterozygous is the key here, and both parents are heterozygous. Heterozygous means different letters, and we're using W's, so different, not different letters, different size letters. So big W, little w, that is what heterozygous looks like for parent one, and it says in the problem both parents are heterozygous for widow's peak, so they're both going to be big W, little w. Okay, so the second step is to set up your Punnett square, and you need to do this in the correct way or you're going to get the wrong answers. So the biggest thing, it does not matter where parent one's genotype goes. It can go on the top or it can go on the side, but it's important that you keep the parent one's genotype letters together. So if you're going to put them on the top, that's great, but make sure each letter stays on the top. So what I mean by that, so we're going to come over here, we're going to do big W, and then the other parent one's genotype is a little w. So that's going to go right there. Parent two can either go on the top or the side. However, we've already done the top, so I'm going to put it on the side. And I did it in different colors here. So parent one is represented in black, and parent two is represented in green. So the next step is to do the Punnett square, and simply put, you are bringing your letters down and you bring your letters across. So right away, we're going to drop down that big W, the black big W. We're going to bring that down to the first two boxes. We're going to do the same thing for the little w. So we brought the letters down, and now we bring the letters across. So big W goes across, and little w goes across. The final step then is going to be figuring out the ratios and the percentages, or percentages, I should say. So I think most people know what a percentage is in this class. If you don't, it is one number or a number in relation to the whole. So 1 out of 4, 4 being the whole, 1 being the one number. So a percentage, a number in relation to the whole, and it's usually represented with a percentage sign. Ratio is a number in relation to another number. So this is what these questions are going to look like then. I could ask you the percentages for phenotypes or genotypes, and I can also ask you for the ratios for the phenotypes or genotypes. So the last step is knowing percentages and then also identifying. So the first question, what percentage of the offspring will have widow's peak? You might need to look back to the beginning of the problem. The beginning of the problem said big W equals widow's peak. So what boxes of the 4 have widow's peak? Okay, this one has, I'm looking for a big W here. So this one for sure has one big W. This has a big W. This has a big W. So 3 out of 4 have a big W, and that means 3 out of 4 is 75%. For the phenotypic ratio, what you can do is you can just count the boxes for each phenotype. So you got to say what are the phenotypes here? Well, we either have widow's peak or it's absent, or like straight hairline. So you can just count your boxes to determine your ratio. So with this, yeah, we've already circled the boxes with widow's peak. So 3 boxes have widow's peak, and then how many boxes are going to be absent? Just this guy right here. Little w means it's absent or a straight hairline. So the ratio is 3 to 1, and that is 3 widow's peak offspring for every 1 offspring that doesn't have widow's peak. This has been a bit of biology with Mr. Rock, signing off.